Okay, here we have a A-level integration question by substitution. This is question 13 from June 2024, page 1. Okay, so part A. Given that A is a positive constant, use substitution, x equals a sine squared theta. We're going to turn the left-hand side into the right-hand side. Okay, so what I'm going to do first, I'm going to rewrite the left-hand side, so we've got the space. A minus x dx. So we're given the substitution x equals a sine squared theta. Okay, let's look. So dx with respect to theta is going to be 2a sine theta cos theta. Okay, and we can spot straight away that 2 sine theta cos theta is sine 2 theta. So dx with respect to d theta is a multiplied by sine 2 theta. So we get dx is a sine theta, 2 theta, sorry, d theta. Okay. So we have, so far, this one here. Okay. So we also have, okay, we've got square root of x. So square root of x is the square root of a sine squared theta, which is root a sine theta. Yeah. Lovely. And what else do we have? Okay. We've also got the square root. So one second, let me just highlight that. That part here will go in here. And we also have the square root of a minus x, which is a minus, and x is up here. So a sine squared theta, that will become a brackets 1 minus sine squared theta, which you can notice 1 minus sine squared theta is a times cos squared theta. So we get root a times cos theta. Okay, and that bit will replace this bit here. So let's put them all together. I'm going to come back to my limits in a moment. So the square root of x is a times sine theta. The square root of a minus x can be rewritten as root a cos theta. And dx is a sine 2 theta d theta. Okay, let's clean this all up. So root a times root a is a times a is a squared. I'm going to put that on the outside, which so far is looking positive because we've got an a squared on the outside here. Sine theta cos theta we're going to put together, and I'll come back to that in a moment. Times sine 2 theta d theta. And we used this earlier, well, I didn't write it by reference there. Sine 2 theta equals 2 sine theta cos theta. So if I halve both sides, so that goes away, we get the following here. So I can replace this sine cos theta with this here. Lovely. And now that can go on the outside here, and these two, well, they're multiplied together, So that's going to become sine 2 theta squared. And there we are. And that is what we're looking for, but we have to get our limits now. So we can just say, well, when x is 0, a sine squared theta is 0, so theta is 0, so that's the lower limit. And when x is a equals a sine squared theta. Divide both sides by a, so 1 equals sine squared theta. So theta is pi over 2. And there's our limits done. We'll just clean up a bit. Fantastic. So that's part A done. Okay, part B. So we want to just integrate this. Well, we have this bit now, and it's going to equal k pi a squared, and we need to find what k is. Okay, we'll go to a new page. Fantastic. Okay, right. Okay, so we want to integrate sine squared 2 theta. Now that is a little bit tricky, but we need to remember that cos 4 theta is cos squared 2 theta minus sine squared 2 theta. Well, cos squared 2 theta is 1 minus sine squared 2 theta minus, again, bring that sine squared 2 theta over. So cos 4 theta equals 1 minus 2 sine squared 2 theta. So a bit of rearranging, we're going to get 2 sine squared 2 theta equals 1 minus cos 4 theta. And we're looking for that sine squared by itself. So sine squared 2 theta equals a half 1 minus cos 4 theta. So we can put that in. So what I like to do here is, instead of me writing a half times that, I'm just going to put a half to the outside. So my outside part will become a squared 1 minus cos 4 theta 0 pi over 2 d theta. Okay, so now I'm going to integrate this. So this is my perfect reference. This is how use that all on the outside. So I get theta minus, well, cos will integrate up to negative sign. So negative sign derives down to minus cos, because sine goes to positive cos. But we've got the 4 theta, so we're going to have a quarter sine 4 theta there. Okay, we can bring that in. Right. And our limits are pi over 2, 0. And let's just remind us what we're looking for. We're looking for a final answer of k pi a squared. Just gives us a bit of that direction. Okay. Well, let's put in our upper limit. Our upper limit is pi over 2 minus a quarter sine. Well, pi over 2 times 4 is, I believe, 2 pi. And then sine, I make sure the calculator is in radians, mine's in degrees. So let me just change that. So sine of 2 pi is 0. So that makes that a little bit easier for us. So that's our upper limit. And we're going to take away the lower limit. Well, put in 0 to theta minus a quarter sine 4 times 0 is 0. So that's a 0, which is nice. So then we're left with quarter a squared multiplied. Well, that's 0, that's 0, that's 0. So we're multiplying by pi over 2. And then my bracket's way too big. So your final answer is 1/8 pi a squared. There we are. And what are we looking for? We're looking for this k value. Final answer, k equals 1/8. And there you are. Follow that in the exam and you'll get a nice 8 marks. Hope that helps.